Okay, Chapter 1, Section 4, Lines. So in this section, we're going to cover the slope of a line, point-slope form of the equation of a line, slope-intercept form of the equation of a line, vertical and horizontal lines, the general equation of a line, and finally, we'll look at parallel and perpendicular lines. So, the slope of a line. The slope of a line is the ratio of rise to run, right? So slope equals rise over run. So if a line lies in a coordinate plane, then the run is the change in the x coordinate direction, and the rise is the corresponding change in the y coordinate between any 2 points on the line. Okay? So a slope is a way of describing the steepness of a line. We grab any 2 points. In this little example, any 2 points on this line, let's go with a darker, say this point and this point, or this point and this point, right? Any 2 points on the line, what we're going to do is think about the change in the x-axis direction. That's what we call the run. And the change in the y-axis direction, that's what we call the rise. So the ratio of those two, this little fraction, tells us the steepness of a line. We also get to determine whether it's rising, going in this direction, like this little camper guy, from left to right. The way we read, if you're going uphill, then you have a positive number. And if you go from left to right, the way we read, if you go down, then you have a negative change in the y coordinate direction, so it's a negative slope. Slope always confuses people. I'm not really sure why. It's, maybe they overthink it too much. Slope is just an arbitrary number, a way of describing the steepness of a line. So the slope m, right, I'm not really sure why, but we often use the lowercase m to represent the slope. So the slope of a non-vertical line that passes through points A and B, where A is x sub 1 comma y sub 1 and b is x sub 2 comma y sub 2, is given as m equals 2 rise over run, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the important thing here is to notice that what we're doing is we're subtracting the difference in the y's, so these two, the difference in the y's, minus the difference in the x's. So we have to make sure that the y's are in the numerator, that's the rise, and the x's are in the denominator. So that's important. But the order in which you do them can change. So just for notational sake, we put y sub 2 minus y sub 1. But we could have also just as likely just put y sub 1 minus y sub 2. Right? The order doesn't matter as long as you are consistent in the denominator. So if you started with y sub 2 in the numerator, you have to continue with x sub 2 in the denominator. If you start with y sub 1 in the numerator, then you can come over here and rewrite this as x sub 1 minus x sub 2. So as long as they're consistent. The only thing you're not allowed to do, which will result in the wrong answer, is if you decide to start with 1 up here, and then decide to continue it with x sub 2 down here. Now you're going to get the wrong sign. So this one's not good, but either one of these two is fine. The little sub-indices are arbitrary. They're just indicating one unique point. This is point A, this is point B. So pick one of them, pick the y-coordinate, subtract the y-coordinate from the other one. Then go back to the one you started with and then subtract the x-coordinates for your denominator. Good. So this is all for non-vertical line. So note that the slope of a vertical line is not defined. The slope is independent of which 2 points are chosen in the line. So for example, to illustrate that, there are several points here. Here's a point A. Let's go with this. Point A is x sub 1, y sub 1. Here it is. X sub 1, y sub 1. Let's highlight it. Point A. And then point B is this guy over here. That's going to be this one. And we've chosen to name it as x sub 2, y sub 2. Right? X sub 1 means that if we trace this down here, there's a little x sub 1 right there that corresponds to the x coordinate. And if we trace it in this direction, this way, this corresponds to a little y sub 1 value there. So they meet to give you your x sub 1 comma y sub 1, or point A. This one is x sub 2, so if we trace this down this way, we'll end up with a x sub 2. And go across this way, we end up with a y sub 2. Right? The little sub-indices are just there to identify that they're different values. Okay, so we have a point A, a point B. If we want to find the slope of this line, what we could do is take these 2 points and look at the change in the rise, the change in the y's, and divide it by the change in the x's. So in this direction, the change in the x's, the run is x sub 2 minus x sub 1. Up here, the change in the y's is y sub 2 minus y sub 1, and that's where this formula comes in. Change in the y's divided by the change in the x's. Now, just to illustrate that it doesn't matter, it's arbitrary which points you use, as long as they're all on the line, you're going to get the same answer. There's a couple of other points chosen on this line. So here we have this point, A prime, capital A prime, capital B prime. They're 2 different points, and they've been identified or labeled as x sub 1 prime, y sub 1 prime. So if we trace this down, that means that there's an x sub 1 prime right there, and that there's an x sub 2 prime right there. So it's just to show you that they're all different values. X sub 1 prime is different from x sub 1. And then we trace this way, we'll end up with a y sub 1 prime from here. And then from here, we trace this way, and we end up with a y sub 2 prime, leading to that guy. Okay, so we can clearly tell that this triangle is not the same as this triangle, right? This triangle up here looks much bigger, right? So therefore, the distance along this direction, the change in this direction, this value is different than this value over here. And likewise, this distance along here is different than this distance along here. So this ratio, notice that my point I was driving at, is notice that x sub 2 prime minus x sub 1 prime, whatever that distance is, this is not the same as this one. Clearly this one is much bigger, does not equal x sub 2 minus x sub 1. And also likewise, in this direction, y sub 2 prime minus y sub 1 prime does not equal y sub 2 minus y sub 1. So they're clearly different. But what is the same is their ratio when you divide them. The ratio, the division of this distance, y sub 2 minus y sub 1, divided by this one, x sub 2 minus x sub 1, is equal to the ratio of these two, y sub 2 prime minus y sub 1 prime divided by x sub 2 prime minus x sub 1 prime, right? So this is referring to this one up here. Using this point and this point, we end up with this. Okay? So the numerator and denominators individually might be different, but the fractions reduce to the same value. They equal to each other. They represent the same thing. So the point of this is that it's you can use any 2 points on a line and you end up with the same slope, right? And remember, a slope is just a fraction that describes the steepness of a line. We know that if we, if you can visualize a little person hiking on here, a little stick person, if that stick person is hiking uphill, then we know the slope is going to be positive. If the stick person is walking downhill from left to right, the way we read, then the slope is going to be negative. The change in the y is what describes whether it's positive or negative. And so here we're going to go in this direction, so we're increasing. Whereas if we have a slope in the other direction, then it would be negative. We'll look at some examples. Okay, so here's several examples. So again, if the line has this general shape from left to right, the way we read, if a little stick person is going uphill, then we know that this is a positive slope. If a little stick person is going downhill, I like to picture them kind of bobsledding. That's the extent of my art skills. So kind of bobsledding downhill, then we know it's negative. If it's flat horizontal, if a little stick person is just standing on flat ground, then it's a zero slope. And then no slope. There's nowhere for this little stick person to stand. Right? He's just falling, a little parachute here. Right? So no slope, nowhere for him to stand. Zero slope, perfectly flat horizontal. Notice that this is independent of where the line is drawn in relation to the quadrants. So a positive slope does not mean that it is in quadrant 1 or quadrant 2. You could have a positive slope and be down here in quadrant 3 or in quadrant 4. So it's not about where the line is drawn. It's about the steepness, the angle of that line. Okay, so keep that in mind. A very common mistake is people think that because it has a positive slope that the line must live in this quadrant where the x and the y coordinates are both positive, and that the negative slope somehow means that the line lives down here where the y coordinate is negative, right? So that's not the case. Lines extend forever, right? So even though it's not really drawn there, this goes this way forever, this goes this way forever. So even if this line is in quadrant 1, the same line is going to be down here in quadrant 2 and in quadrant 3, and same for this one. This goes this way, this goes that way. Okay, find the slope of a line. Okay, finding the slope of a line through 2 points. So find the slope of the line that passes through points points P and Q, where P is 2, 1 and Q is 8, 5. Okay, so using our formula, let's go back to our formula. We know that if we have a point x sub 1, y sub 1, and some other point x sub 2, y sub 2, then our slope formula m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so all you have to do is label these things, and it doesn't matter which is which. Just be consistent. So I'm just going to call this one x sub 1, call that one y sub 1, and call this one x sub 2, and call this one y sub 2. Okay, so with this in mind, that means that the slope is then going to be equal to y sub 2, which is a 5, minus y sub 1, which is a 1, divided by x sub 2, which is an 8, minus x sub 1, which is a 2. Okay, so I started on this one, 5 minus 1 in the numerator. So in the denominator, I have to start with this one, 8 minus 2. It would be wrong if I wrote 2 minus 8. Good, so then this would be 4 over 6, which reduces to 2 over 3. So the slope is 2/3. Good. Likewise, these numbers are arbitrary, so I could have done it this way. Let's do it the other way. If I decided to label it as, let's see, P is 2, 1, and Q is 8, 5, I could start and over here and say, let's label this one x sub 1, let's label this one y sub 1, let's label this one x sub 2, and therefore this one y sub 2. Okay, so then when we come up with our slope, m equals 2, and so if I stick to my little formula with a little index of sub 2, then this becomes 1 minus 5. And initially you're thinking, oh, we're going to get the wrong answer because here it was 5 minus 1, that's a 4. Here we're going to get 1 minus 5, which does equal to negative 4. But in the denominator, we're going to get another negative. So I started with this one, 1 minus 5. So in the denominator, I have to continue with this one. So it's going to be 2 minus 8, which gives me a negative 6. Now the negatives cancel to reduce back to our 2/3. Okay, so it's arbitrary. It doesn't matter how you label it. As long as you're consistent with your labeling, you'll get the correct answer. Okay, so again, the one thing you cannot do is mix and match. So if you decided to write it as m equals to 1 minus 5 and then decide to put the denominator as 8 minus 2, that's going to result in negative 4 divided by positive 6, which will then reduce to negative 2/3, and that's the wrong answer. So that's the one thing you cannot do. You can't mix and match them. If you choose to start with this point for the numerator, you have to continue with the same point for the denominator. So here's the solution provided by your author. As you can see, it's the same thing. We subtracted 5 minus 1 over 8 minus 2, reducing to 2 over 3. And now if we wanted to graph the line, we have a coordinate system here, a Cartesian coordinate system. And so this point corresponds to 2 along the x-axis. So here's a 2, and this corresponds to a 1. And then over here we have a value that corresponds to an 8 along the x-axis direction, and then a 5 along the y. So if we wanted to think about the rise over run, we often like to think about these triangles. So grab the 2 points, go across, and then come down. And then that forms a right triangle right here, where this represents the run and this represents the rise. So here is the rise, which we saw was equal to the change between a 5 and a 1, which is equal to 5 minus 1, which is equal to 4. In this direction, we have the run, which is the 8 minus 2, which is a 6. Okay, so then the ratio is 4 over 6, which reduces down to 2/3. Okay, so another way to interpret a slope is to say that once you have a point on the line, then for every 3 units that we move to the right from that point, we move up 2 units. So for every 3. So for instance, starting at this same point, we can go 3 units this way, 1, 2, 3 units this way, and then we go up 2 units, and we arrive at another point on the line. All right, so this is the reduced fraction of 3 units this way, 2 units this way, so 2 over 3. Okay, so for every 3 units in the x-axis direction, starting at a point on the line, then we go up 2 units. Okay, the point-slope form of the equation of a line. So the point-slope form of the equation of the line, an equation of the line that passes through the point x sub 1, y sub 1, and has slope m, is given by this formula. Notice that this formula is really just the formula for slope, right? So earlier we saw that slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we take this equation and we multiply both sides of the equal sign by this denominator, so multiply this side by x sub 2 minus x sub 1. Whatever you do to one side, you must do to the other, so multiply the other side by x sub 2 minus x sub 1. Now this cancels with this, giving me x sub 2 minus x sub 1 times m equals y sub 2 minus y sub 1. Okay, so what we want to do now is think about the fact that this formula comes from the 2 points that are given, right? So we have x sub 1, y sub 1, and we have x sub 2, comma y sub 2. These are 2 points on the line. So now if we use one of them to be a given point, a constant on the line, and the other one is an arbitrary point, which we're just going to leave as x and y. So now if we use x sub 1 comma y sub 1 to be a given point, and we let x and y, without any subscripts, just be any arbitrary point, right? Any ordered pair that's on the line, then we get this formula right in here. So the m then becomes y minus y sub 1 instead of y sub 2 minus y sub 1 all over x minus x sub 1. And again, we can solve it like over there and end up with m times x minus x sub 1 equals to y minus y sub 1. And then here all they did is just flip it around. So then we end up with y minus y sub 1 equals to m x minus x sub 1. Okay? All right, so that's where this formula comes from. And its value is in that if you have a case where you're given a point and maybe you already know the slope, then if you know the slope and a point, then you can fill in these values for the point, right? So given this value and this value as a point you know, and slope as something you know, then you can fill them in here and come up with the equation of a line. This is called the point-slope form of the equation of a line. For example, find the equation of a line given a point and slope. So find the equation of a line through point 1 comma negative 3 with slope negative 1/2. All right, so if we want to use the point-slope form of a line, it is y minus y sub 1 equals m x minus x sub 1, where x sub 1 and y sub 1 are a given point, so we just have to label them. So let's just call this x sub 1, and we'll call that y sub 1. And then this guy is our slope, m equals to negative 1/2. So we just fill them in here. So y minus y sub 1 is negative 3. Be careful to carry your sign. Equals to negative 1/2 times x minus x sub 1, which is a 1. So we're almost done. We just want to simplify this a little bit. Subtraction of a negative results in a positive. So this would become y plus 3 equals to negative 1/2 x plus 1/2. And then we can subtract 3 from both sides to solve for y. Or we can multiply everything by a 2 to get rid of that fraction. Let's do that. So I'm going to multiply this side by 2, multiply this side by 2, and I end up with 2y plus 6 equals to negative x plus 1. Right? As this 2 and these 2 cancel, this 2 and this 2 cancel, so we end up with this. Now, to do a sketch of it, I'm just going to go back to the original information given. It's easier to do a rough sketch based on this information than it is from the equation down here. So, since we already know that one point on the line is 1 comma negative 3, this is a point on the line, and we know the slope, we can use the rise over run method to figure out another point on the line, and then I can connect those 2 points and draw my line. So just a rough sketch. Let's do a grid. Okay, so let's say that this counts as, say, a 1 right there. And then this goes down 3 units. 1, 2, 3. So the point, let's put it in a green dot. The first point would be something like right there. So this corresponds to the point 1 comma negative 3. 1 comma negative 3. This is a negative 3 here. Oops. This is a negative 3 there, and this is a 1. Okay, so then using this information, I know that if we go 2 units to the right, so take your slope m equal to negative 1/2, and rewrite it as this, so that the negative goes up in the numerator, and now this is my run, and this is my rise. Rise over run. So always think about the run as a positive. Go in this direction. So we're going to go 2 units to the right. 1, 2 units. 2 units this way. Here, let me make space here. Okay, so we're going to go 2 units to the right. Right? We started at 1. So if we go 2 units this way, we're going to end up at 3. Right? So that's going to result in a 3 there. And then we go down 1 unit. Right, so over to 3 and then down by 1 unit. And we started at -3, so minus 1, right, because the rise is -1. We end up with another point on my line that's over here, and that point is going to correspond to -4, since we started at -3 and we then went down by 1 more unit. This is -4. And now we can connect that line right there, and that'll be our line. Sort of. Okay. So there you go. Here's a nicer picture provided by your author. So again, if we sketch the first point, we drop in the point 1, 3. That's this point right in here. And then we look at our slope. And now remember, our slope can be thought of as -1/2, like this. But we really want to think about putting that -1 up in the numerator, -1 over 2. And then think of this as my rise over my run. So the run is 2 units this way, and the rise is down 1 unit because it's negative. And that helps us arrive at the second point. So here we started at a value of 1 along the x-axis. We go 2 units this way, which means we end at a value of 3. And then along the, okay, so that means that this ordered pair is going to be 3, comma. And now in the y-axis direction, we started at a depth of -3, and then we went down by another -1. So we end up at a depth of -4. And so the second ordered pair we found on our line is 3, -4. Okay, so we have 2 points. All we have to do is connect them, and that's how we draw our line. Okay, the slope-intercept form of the equation of a line. Suppose that a non-vertical line has slope m and y-intercept b, such as in this picture. Notice that the y-intercept is the point where the line crosses the y-axis, so that would be 0, b. And it has slope m, okay? This means that the line intersects the y-axis at point 0, b. So the point slope form of the equation of the line has x equal to 0 and y equal to b, right? So this is the ordered pair. This is using the formula from before of y minus y sub 1 equals m x sub x minus x sub 1, where we're using a x sub 1 value, the known value, to be a 0, and the y sub 1 value to be a b value, b, right? That's what we're using here. We're letting this be x sub 1 and this be y sub 1. Okay, all right, so now when we do that, then this simplifies. This becomes y minus b equals mx minus 0 times m. 0 times anything is 0, so this just becomes y minus b equals to mx. And now if we add b to both sides, we get y equals to mx plus b. Okay, so this simplifies to mx plus b, which is called the slope-intercept form of the equation of a line. All right, so there's more than one way to describe a line. That's what we want to get out of this. There is the point-slope form, and then there's the slope-intercept form. Both describe a line, and there's also other ways to describe lines. There's the general formula for a line, which we'll get to in a little bit. But so far, we have 2 ways to describe a line. This is one of them here. This is given y sub 1, x sub 1, and m. This is a useful way of describing a line. Or also, if you're given the slope and the y-intercept, then this becomes a new way to describe a line, right? So this one's useful if you know m and if you know b, the y-intercept. And this one is useful if we know the slope and we know one point, any point on the line, then we can use this formula. Okay, find an equation of the line with slope 3 and y-intercept at -2. Okay, so if we just use our formula, we know that y equals mx plus b. We know that y equals mx plus b, where m is the slope. And so for part A, the slope is given right here. Slope is 3. So I know that m equals 3. And the intercept, the y-intercept, is given to be -2, which really means it's 0, -2. And so the b is -2. b equals -2. Good. Well, this is the solution for a. All right, so now all we have to do is substitute it into here. Very easy. Y equals to 3x plus -2, or y equals to 3x minus 2. Good. Okay. Find the slope and y-intercept of this line. Okay, so now we're given an equation. What we want to do to find the slope and the y-intercept is manipulate this, use our algebra skills to rewrite it in the form of y equals mx plus b, and then we can just interpret the values from our equation. So we want to solve for y. For b, let's solve for y. So we get 3y minus 2x equals 1. I'm going to add 2x to both sides, plus 2x plus 2x. I end up with 3y equals to 2x plus 1. And then I want to divide everything by 3 or multiply everything by 1/3. So multiply this side by 1/3. Multiply this side by 1/3. And so our result is going to be y equals to 2/3 x plus 1/3. This fits the form of y equals mx plus b. Fits form of y equals mx plus b, where the m is being played by a 2/3 and the b is being played by a 1/3. So from there I can tell that the slope is 2/3, and the y-intercept is 0, 1/3. Okay, vertical and horizontal lines. Okay, vertical and horizontal lines. An equation of the vertical line through a comma b is x equal to a. So this statement right here is the equation of a vertical line. Remember, vertical lines are straight up and down, vertical. The slope is not defined. On the other hand, a horizontal line, the equation of a horizontal line, remember horizontal lines have slope equal to 0. They're flat and they go through the point, if it goes through the point a comma b, then the equation is y equals to b. Okay, let's look at an example. Okay, let's take a look at this example. So an equation for the vertical line through the point 3, 5 is the line x equals to 3. So remember, the notation's a little weird. Sometimes people get confused because this looks like you're letting x equal the number 3. But in terms of lines, you got to pay attention to the context. In terms of lines, this represents a line. It's the equation of a vertical line. Okay. The graph of the equation x equals to 3, so it's an equation. It's not just, when you're doing like substitution or evaluating an equation, you're letting x equal to a number 3. Here, it's a little bit different. It's the graph. It's the equation of a vertical line. Is a vertical line with x-intercept at 3. So that is like this red line right here. It's a vertical line. It's the line x equals to 3. X equals to 3, and notice that it goes through the point. Here's the point 3, 0. The line 3, 0. Okay. On the other hand, an equation for the horizontal line through point 8, -2 is the line y equals to -2. Y equals -2. Again, that's the equation of a line. And the graph of the equation of y equals to -2 is a horizontal line with a y-intercept at -2. So that's like this blue line down here. And again, notice that it goes through this point right there, which is the point 0, -2. That's the y-intercept point. And it's the line y equals to -2. Notice these two also cross right there at the point 3, -2. Okay, the general equation of a line. So a linear equation in the variable x and y is an equation of the form ax plus by plus c equals to 0, where again the a, b, and c are constants, and the a and the b are not both 0. Because if they were, then the thing would just overly simplify, get rid of all your variables, and then you'd end up with c, right? If both a and b were both 0, then both would cancel. We would just end up with c equals to 0, which is not what we want. Okay, so the a, the b, and the c represent any constants. And really, it's just the x and y that represent our variables, right? Where x is usually the independent variable and y usually represents the dependent variable. Okay, so a non-vertical line has equation y equals to mx plus b. We ran into that form of a linear equation before. So if we just simply move everything to one side, right, that's all we're doing here. We're taking this and subtracting minus mx to both sides, minus b. That's how we arrive at this equation. And so now this fits this form where the negative m is an a and the b is being played by this sort of invisible 1 out in front. And the c is, let's put it in blue, the c is this negative b, right? So a equals negative m, b equals 1, and c equals to negative 1. Okay, so just showing you that we can take the equation of a line and manipulate it and make it fit this more generic form of an equation of a line. A vertical line has equation x equals to a, right, where a is some constant. So again, if we just subtract a for both sides, we get this. And now again, this fits this form where the capital A is, oh, let me put it up here. Let me put it in yellow. The capital A is this constant out in front, which is a 1. And the by, there is no y, so therefore the b is a 0. We can also rewrite this as x plus 0y minus a equals to 0, right? And 0y is just 0, so it would go away. So this is the same thing as x minus a equals to 0. But then there's this invisible 1 out in front. And so now the a is a 1. The b is this 0. This 0, that's this one. And then the c is this minus a. So again, just showing you that we can take an equation of a line which fits this form, manipulate it, change it around, and then it fits this generic equation of a line, this format. Same thing with the form of y equals mx plus b. So we have 3 different ways in which we can represent the equation of a line. We have y equals mx plus b, my personal favorite. We also have y minus y sub 1 equals mx minus x sub 1. And we also have ax plus by plus c equals to 0, right? 3 different ways to represent the line. They all can be manipulated to make one fit the other. So it's not like we have 3 different ways that are unconnected. They're all connected to each other. And in most problems, one version might be more useful than another, but you should know all 3 of them. Okay, sketch the graph of the equation 2x minus 3y minus 12 equals to 0. So notice that this fits the form of a linear equation of the form ax plus by plus c equals to 0. This is where the a is being played by a 2. The b is being played by a negative 3. And finally, the c is being played by this negative 12. So it fits this form. We know it's a line. Once we know it's a line, then we know that to graph it, we just need 2 points, any 2 points. So when you have an equation in this form, one of the easiest ways to sketch the graph is to find the x and the y intercept points. So to find the x-intercept point, what we're going to do is substitute the y for 0, right? So the x-intercept is where the line crosses the x-axis, which means that the y value will be 0. So let's copy this equation over here, boom, and we're going to do 2x minus 3 times 0, I'm going to put a 0 there, minus 12 equals to 0, letting y equal to 0. So put a 0 there. When we let y equal to 0, then 3 times 0 is 0. So this whole term just goes away, becomes 0. And so this simplifies to just give me a 2x minus 12 equals to 0. And then that makes it really easy for me to solve for x. So now if I add 12 to both sides, plus 12, plus 12, we end up with 2x equals to 12. And now I multiply both sides by 1/2 to isolate the x. 1/2 times 1/2. The 2's cancel. So I end up with x equals to 6. Okay, so now I have the ordered pair 6, 0, right? This is the x-intercept point. X-intercept. Good. All right, so now the y-intercept. To find the y-intercept, the place where the line crosses the y-axis, well, that's going to be when x equals to 0. So again, we come back to our equation, and this time we replace the x with a 0. So it'll be 2 times blank minus 3y minus 12 equals to 0. And we're going to replace the x with a 0. And so 2 times 0 is 0. That means this whole term becomes 0, goes away. So the only thing that survives is a minus 3 minus 3y minus 12 equals 0. Then we add 12 to both sides, plus 12 plus 12. And so we end up with negative 3y equals to positive 12. And next we multiply both sides by negative 1/3. Negative 1/3 times negative 1/3. And so on the left-hand side, we've solved for y. Y equals negative 4. So now we have the ordered pair 0, negative 4. And this is our y-intercept. Okay, and so now once you know 2 points on the line, any 2 points, we know the x-intercept point, we know the y-intercept point, we can just draw those 2 points and connect them, and that's the equation of our line. So here's a nice graph for that. So notice that here we have our y-intercept point at 0, negative 4. Here we have our x-intercept point at 6, 0. So this one is the y-intercept. And this one is our x-intercept. Okay, so we draw those 2 points. They were easy to get. Then we draw the line that connects them, and that's the equation of our line. Okay, solution number 2 would then be to rewrite our original equation. Remember, I pointed out that this fits the form ax plus by plus c equals to 0. So that's what this kind of fits. The a is the 2. The b is this negative 3. That's our b. And our c is this negative 12. That's the c. So it fits this form. However, a more useful form would be the slope-intercept form. Remember, the slope-intercept form is the y equals mx plus b form of a linear equation. So all we have to do is solve for y here, put it in this form, and then once we have it in that form, we can read from the equation what the slope is and what the y-intercept is. And from that, we can do a nice sketch. So that's a very common way to do this. All right, so let's work with 2x minus 3y minus 12 equals to 0. And our goal is to isolate the y, solve for y. So I'm going to subtract 2x from this side, subtract 2x on this side, and I'm also going to add 12 to this side, add 12 to that side. And so what results is this becomes 0, this becomes 0. We end up with minus 3y equals to minus 2x plus 12. And then I'm going to multiply everything by negative 1/3. So multiply this side by negative 1/3, multiply this side by negative 1/3. And so I end up with y equals to negative 2 times negative 1/3 becomes positive 2/3 x. and 12 times negative 1/3 becomes minus 4. Okay, so now this fits the form of the slope-intercept form, where now the m is 2/3 and the minus 4 is the b. Right, so from this form, I can tell that the slope is equal to 2/3 and that the b value is going to be equal to negative 4, which means that the y-intercept is the point 0, negative 4. Okay, and so now that we have a point on the line, 0, negative 4, and we know this slope, we can come up with a sketch of the line using the fact that the slope is the ratio of rise over run. Okay, so starting at this point right here, we have the point 0, negative 4. That was our y-intercept. Was that guy right there, so there. And then we're going to use our slope, which was equal to 2/3, which means that this is the rise, this is the run. So starting at the point 0, negative 4, we're going to go in this direction by 3 units, because the run is 3. And then we're going to go up by 2 units, because the rise is positive 2, so we go up. And that helps us arrive at another point on the line. So we started at a depth of negative 4, and we went up by 2. That means that this is the number negative 2. And then we started at 0 and went this way by 3 units, so we ended up at 3. So that means that this is the point 3, negative 2. They didn't ask us for it, but it's nice to identify it. So we have now 2 points on the line, and we can draw the line that connects them, and that's how we can sketch the line using the point slope intercept. Okay, parallel and perpendicular lines. So parallel lines are two non-vertical lines are parallel if and only if they have the same slope. For example, find an equation of the line through the point 5, 2 that is parallel to the line 4x plus 6y plus 5 equals to 0. Okay, I'm going to use a technology to illustrate what this is really asking. So I like to use Desmos. So this is desmos.com. I'm using their graphing calculator. It's a great online tool. Make sure you're allowed to use it. Just make sure you're using it to learn, not just to copy things. So back to our question. I want to graph 4x plus 6y plus 5. And then the point, so it's this equation, and then we have the point 5, 2. Okay, so now we can graphically see this question. So here is the given line that we're working with, 4x plus 6y plus 5 equals to 0. That's this black line right here. And then there was a separate point, 5, 2, which is over there. Very importantly, notice, obviously, the point is not on the line. If this was a point on the line, then there would only be one equation, right? So what we're looking for is for another equation of another line that goes through this point, but is also parallel to this one, right? It makes like railroad tracks. So I need to find the equation of that line. Two lines are parallel if they have the same slope. So step number 1 is going to be to figure out the slope of this black line. To do that, all we have to do is manipulate this equation, come up with the point slope intercept form of a linear equation, and then again we can just interpret the slope right from our equation. So let's do that. Okay, so I'm going to rewrite this or work with this. I have 4x plus 6y plus 5 equals to 0. To solve for y, I'm going to subtract 4x from this side, subtract 4x from this side. Then I'm going to subtract 5 from this side, subtract 5 from this side. So these guys will cancel, these guys will cancel. Survivors will be 6y equals to minus 4x minus 5. Then I'm going to multiply everything by 1/6. So times 1/6 times 1/6. that'll solve for y. So y equals to negative 4 divided by 6x minus 5 over 6. This fraction does not reduce, but this one does. So y equals to negative 2/3 x minus 5 over 6. Okay, what this is another equation of a line which is equivalent to this one. So these two have the same graph. They have the same ordered pairs. Every ordered pair that makes this one a true statement also makes this one a true statement. Okay, so if we graph this equation, we should get the exact same line. Let's go back to Desmos. And there, if I type in the same equation, notice that this black line and this green line are the same. I can just turn it on and off, and you see that the black line and the green line are the same. This helps us confirm that both graphs are identical. Remember, the graph represents all the ordered pairs that are solutions to this. There's an infinite number of ordered pairs, such as, say, this one. The computer just grabbed one point that's on there, the y-intercept. This is an ordered pair that's a solution to this green one. And it's also a solution to this black line, right? It's on both lines. Every ordered pair that's a solution to this equation is also a solution to this equation. So they both have the same ones. And the advantage is now that I can very easily tell what the slope is from right here. The slope is negative 2 over 3. So if I want to find another equation that is parallel to this one, I have to use the same slope. That was really the point of this. So I have to use the slope negative 2/3, and I have the point 5 comma 2, and I can use that to figure out my equation. Okay, so now we're going to let m equal to negative 2/3, and we want to use point 5 comma 2. All right, so now let's use this form of a linear equation. Right, so this one's useful because now we have the slope right here. That's this. And we have a point. This one and this one can be this point and this point. So this is going to be my x that belongs right here. And this is going to be my y that belongs right there. So I can just label them x sub 1 and y sub 1. Okay, so let's plug them in, and we get y minus 2 equals to negative 2/3 x minus 5. Again, I can type this into Desmos, and it would graph exactly what we want. But usually we like to simplify things, so let's put it back into this form, the slope-intercept form. So let's distribute this fraction. We get y minus 2 equals to negative 2/3 x plus 10 over 3. So negative 2/3 times negative 5 gives you positive 10/3. And then I'm going to add 2 to both sides. Plus 2 plus 2. I get y equals to negative 2/3 x plus 10 over 3 plus 2, and I'm going to rewrite the 2 as a 6 over 3, right? Multiplying it by 3 over 3, and that gives me to 16 over 3. So y equals to negative 2/3 x plus 16/3, and that's our answer. This is the equation of a line parallel to this one that also goes through this point. Okay, so they have the same slope, but the y-intercept is going to be 16/3. So let's try that on Desmos. There, so we have this equation, which is this purple one. As you can tell that they're parallel to each other, except the purple one now goes through this point, 5 comma 2. Good. Notice that there's a whole family of lines that are parallel to the original one. This green one was the original one, right? Well, actually, this black one was the original equation. We manipulated it to fit the slope-intercept form, which was this one. But at any rate, whether it's the green one or the black one, either way, that was the original equation. And there's in fact an infinite number of lines that are parallel to it. And we can identify them with decimals really nicely. So if I just type in y equals to -2 divided by 3x plus some constant, let's call it c. We're going to let c be a slider. Let's put this one in a different color. Let's put it in red. Okay. All right, so then this red line, what Desmos is doing now is it's letting c be a constant. And so in this case, c is a 1. And I have a little slider here so I can move it around. I also want to, let's go ahead and graph the place where it crosses, which is going to be 0, c. So if we graph 0, 0, c and label it, we get this. So at the moment, c is a 1. So that's why it's graphing the point 0, 1. But then as this changes, see, we can get an infinite number of lines that are all parallel to that green one, right? But there's only one parallel line that also goes to the point 5, 2. And that's where we arrive at this, right? But there's really an infinite number, right? If they just said come up with a parallel line, well, you have to be more specific because there's just so many. But they give us the second condition of it going through a particular point for us to identify the particular equation that we need. Good? Okay. All right, perpendicular lines. Two lines with slope m sub 1 and m sub 2 are perpendicular if and only if, when you multiply m sub 1 times m sub 2, the answer is -1. That is, their slopes are negative reciprocals. So it depends on how you remember it. I remember being told, and I've memorized this, that they're negative reciprocals, opposite sign and reciprocals. But I think this is, a little easier to remember, I think. So I really like to push this now. When you multiply their slopes, the answer is -1, right? So these two are equal to each other. If you just divide both sides of this equal sign by m sub 1, you get to this equation. So they're both the same. It's just, I think, a little easier to remember this. Two lines are perpendicular if when you multiply their slopes, the answer is -1. Note that a horizontal line has slope equal to 0 is perpendicular to a vertical line which has no slope, right? That's sort of the obvious case. If we have a vertical line like this and we have a horizontal line like this, then they're going to cross and make a 90-degree angle. They're perpendicular to each other. So just keep that in mind, that this doesn't really fit this description. This is for any other two lines that don't include a vertical. So for example, say that line and that line, do they make a 90-degree angle? All right, well, to do that, we're going to have to find the slope of this one, m sub 1, the slope of this one, m sub 2, and then multiply them. And if when you multiply them, the answer is -1, that's how you know that those two lines are actually perpendicular to each other. Okay, so again, let's use Desmos to illustrate perpendicular lines. So remember, any two lines where their slopes multiply to -1 are perpendicular. Okay, so let me write down a linear equation of the form, let's just put x plus a, where a is going to be a slider. Right, so a just moves up and down. Let's go ahead and label the point 0, a. So that labels the y-intercept point, right? And again, as we slide up and down, we just get that line right there. And let's do a separate line, again, of the form y equals to -x plus b, where b is another slider. And again, I'm going to label the point 0, b. That way we get the y-intercept of that line. Let's make them different colors. So let's make this line blue and we'll make this line green. There we go. Okay, so as I change the value of b in this equation, that slides up and down the blue one. And then as I change the value of a in this equation, that slides that one up and down. Okay, so here I have a 1 in front of the x, so that means the slope is 1. And the slope in this one is -1. And as you can see, it creates a 90-degree angle. And depending on the value of the constants a and b, there's really an infinite number of combinations that can happen. Okay, but that's not, there's nothing special about the 1 and -1. They work because they multiply to -1. 1 times -1 equals -1. But it could be any other value. So I'm just going to randomly pick a couple values here. How about 6 divided by 11? So here is, the green one now has a slope of 6 divided by 11. And in order to guarantee that I have perpendicular lines, I got to come over here and make this one a -11 divided by 6. Now that, again, guarantees that they equal to, that they're perpendicular, because when you multiply 6 over 11 times -11 over 6, they multiply to give you -1. That's how we know that these two lines are perpendicular. And again, if you just change the y-intercept values, then you get different results. But all of these cases result in a 90-degree angle, right? So these guys are always perpendicular independent of where it is that these values go. As this moves up and down, or this one moves up and down, they always maintain a nice 90-degree angle here. All right, for example, show that points 3, 3, 8, 17, and 11, 5 are the vertices of a right triangle. Okay, so let's kind of graph these out. So we have a dot right there at 3, 3, and one at 8, 17. 8, 17, that's somewhere over here. And then 11, 5, that's somewhere over here. Good. So you can kind of try and insert lines here. Let's see if we can draw this out. Okay, so we have 3 dots on this grid, and it's not super necessarily clear which ones are potentially perpendicular to each other. Just the way I drew it, it seems like maybe these might be a right angle. But sometimes, you can't rely on your own hand-drawn pictures. It might turn out that, in fact, maybe these are the right angles, okay? So you can't just eyeball it and give an answer. You have to rely on the formula. So what we need to do is come up with the slopes of all 3 lines. There's 3 segments, right? So I'm going to call this one m sub 1. I'm going to call this one m sub 2. And I'm going to call this one m sub 3. The slopes of these individual lines. And then I want to see if when I multiply 2 of these, the answer is -1. That'll confirm for me that we have 2 lines that are perpendicular to each other. If they're perpendicular to each other, they form a right angle, a 90-degree angle. And therefore, that would create a right triangle here. Okay, so for the case of m sub 1, I'm going to work it out in this little area here. And then for m sub 2, I'm going to work it out in this little area. And then over here, I'll work out m sub 3. Okay, for m sub 1, I'm working with this point and this point, right? Those are the 2 points that are on this line. And so that would be the point 8, 17, 8, 17, and the point 11, 5, 11, 5, right? So those are the 2 points that make up this line, which results in m sub 1. So m sub 1 is then equal to 17 minus 5 over 8 minus 11. So m sub 1 is equal to 12 divided by -3, which means m sub 1 is equal to -4. The sign makes sense because the little stick person would be walking downhill. Okay, so m sub 2 involves this point and this point. That would be the point 3, 3 and the point 11, 5. 11, 5. So m sub 2 is equal to 3 minus 11 over 3 minus, oops, messed up. That's not true, that's not true. Be careful. So I meant to do 3 minus 5 over 3 minus 11. m sub 2 then is equal to negative 2 divided by negative 8. So m sub 2 is equal to positive 1/4. Finally, m sub 3 involves this point and this point, so that would be the point 3, 3, and the point 17, 8, 17. So m sub 3 is equal to 3 minus 17 divided by 3 minus 8. And sub 3 is equal to negative 14 divided by negative 5, or m sub 3 is equal to positive 14 over 5. Okay, so now our goal is to see if when we multiply two of these, the answer is negative 1. And right away we could see that these two work out. Note that if I multiply m1 times m2, which in my case right now is a negative 4 and a positive 1/4, the answer is negative 1. So that confirms for me that these two lines are perpendicular, right? So let me come back over here and erase this one. This one isn't true because that's m3 and m2. M3 and m2, if I multiply these two together, 1/4 times 14 over 5, that does not equal negative 1. So this line and this line do not make a perpendicular line. That's m2 and m3. And same thing with 1 and 3. 1 and 3. If I multiply negative 4 times 14 over 5, that does not equal negative 1. So again, this line and this line do not make perpendiculars. But this line and this line did. That forced a perpendicular. That means that this is 90 degrees. Therefore, this is a right triangle because one of the interior angles is 90 degrees. Okay, I hope that's enough to help you with your homework. Please let me know if you have any questions or feel free to drop by my office hours.